Okay, after that little distraction, my Chinese wife just came home. I don't think she understands that I cannot concentrate, thinking math and this stuff, if she's present in the room. It doesn't work, because then the right half of my brain fires up, and I just can't concentrate on one thing. Maybe the female brain can do that. It's supposed to have a bigger callus callosum, corpus callosum, the great massive fibers that connect the two hemispheres. Women are supposed to be better at multitasking than men. So when I'm doing this stuff, I'm very left brain, and I need to concentrate. I don't want the distraction coming from all the emotional. I mean, she's my wife, right? So I just can't concentrate when she's around. So we just had a bit of an argument. All right, now I'm trying to get back to the left brain stuff. Okay, so it's a function. So you're mapping a member of one set into a member of another set. So what is this set? What are the members of this set? Well, they're an ordered pair. It's a Cartesian product, right? The first member of the pair is a state, the current state, and the second member of the pair, ordered pair, would be a symbol, an input symbol, or the eta, depending what the label is on the transition arrow. Okay, so it's either an input symbol in the input string. Yeah, it's one of the symbols in the input string. In other words, it's a member of capital sigma, or it's the eta. So okay, so you map that pair of current state and input symbol augmented with eta gets mapped to a member of this power set. Now, what is a power set? What are the members of power set? Well, they're just subsets. They're just subsets of the states of the set big Q, right? And that's what happens in an NFA. Depending on what the current input symbol is, and if there's an eta, you may get more than one. It's possible you may get more than one next state generated. That's characteristic of an NFA. Okay, so you may get a set. You may get a set of them, a set of states generated. Well, that set of states would be a member of the power set, right? Because the power set covers all possible subsets. So you can't go wrong, right? Any subset will be a member of the power set, right? So that's then your formal definition for the transmission function, right? Your delta. Okay. All right. So now we can write out the formal definition. So we'll call it, well, the text calls it 1.37. Okay, for the NFA, and it too, just like the DFA formal definition, it will be a 5-tuple. Okay, here it is. So it's much the same as what you're used to. Notice the sigma here is not sigma eta, it's just sigma. Noteworthy. So again, just capital Q, capital sigma, delta, Q naught, and capital F. So in fact the same as for your DFA. All right. Now a couple of notes. So note 1 corresponding to this, 2 corresponding to that, and so on. So Q, capital Q is just a finite set of states, no change, same as with a DFA. Sigma is a finite alphabet, so same as DFA. Now delta is different, right? I mentioned that a bit before. Now we just talked about defining the delta, so just plug this in here. Here it is here. Okay, so that's your transition function, and we talked about what's going on. So it just plugs in as your third item, right? And that's the essential difference between the formal definition of a NFA and a DFA. that is the transition function. And in the starting state, that's no change. And the set of except states also no change, right? Okay, so now an example, so 1.38 in the text. An example of what? An example of a formal definition of an NFA. Now, we've seen this before. It's N1. So earlier, in the previous session, we did N4. So going back to this machine, this automaton N1. Okay. Can you? So we're now on the second square of this session. We will write out the formal description of this automaton, this NFA, non-deterministic finite automaton. Now, can you remember its function? Can you remember its language that this automaton recognizes? Let's see if I can remember it. It was the language consists of all strings which have as a substring either 101 or 11. Okay, we did that in some earlier session. Okay, so this NFA recognizes those strings that have those two possible substrings. Okay, so look at the thing now. Remember, it's a state diagram, pretty simple. We've only got 4 states, so we should be able to construct the formal definition from the state diagram, state transition diagram. Okay, so let's do that. You're going to need to see this, and that's going to be a bit of a problem. Well, okay. I'll stay where I am for the moment, then later switch. So now we're trying to find the formal description of this NFA N1. Okay. So Q, capital Q, the set of states. Well, I just obviously right Q1, Q2, Q3, Q4, which is here. I don't know if you can see it. Okay. So that's your Q. So that's pretty easy. The alphabet. What's the alphabet? Just the binary alphabet, right? So sigma is just 0 and 1. Now 3. Yeah. Now I'll switch. I'll switch over. Here's. Now the third item, the delta, the transition function. That's the hardest part of specifying an